Well, good afternoon, everyone, and welcome to the Pacific Salmon Commission Seminar Series on Environmental Variation and Pacific Salmon Management, the view from both sides of the border. My name's John Holmes, and I'm the Canadian co-chair of the Coho Tech Committee, and I'm pleased to introduce the 16th seminar in our monthly series. This seminar is titled Updates on Current Conditions Around the Northeast Pacific Ocean and features Dr. Andrew Leising from NOAA Fisheries Southwest Fisheries Science Center, who will be speaking on marine conditions in the California current and marine heat waves. Dr. Jennifer Boldt from Fisheries and Oceans Canada Ecosystem Science Division and chair of the State of the Pacific Ocean process that's run annually by DFO, who will be speaking on marine conditions in Canadian marine ecosystems, and Dr. Bridget Ferriss from NOAA Fisheries Alaska Fisheries Science Center, who will be talking about marine conditions in Alaska this year. So our seminar today is going to be a little different in that we have three speakers who are going to be hopefully talking about near real-time information on marine conditions along the west coast of North America, from Alaska down to California and through the transition area in British Columbia. These talks will be followed by some observations on exceptional salmon returns in 2023 from Marisa Litz to bring home the idea of connectedness amongst biophysical elements of these ecosystems. So while you're listening and thinking about questions asked, please consider whether this kind of information, this near real-time information on marine conditions and returns would be valuable for how you assess and manage salmon and stocks entrusted to your stewardship. Based on what you've heard through this seminar series and today, is there something that we can adopt or do differently that will have a material impact on the outcomes for salmon? We need to incorporate new ways of delivering the science needed for a changing environment into our conservation and management approaches so that decisions are informed by this changing context. And this is in part the idea behind this seminar series. Now, before we go any further, let me introduce our speakers. Dr. Andrew Leising received his bachelor's degree in biology and marine science from the State University of New York at Stony Brook, and his doctorate in biological oceanography from the University of California, San Diego, the Scripps Institute, and followed that with a postdoc at the University of Washington. He's worked at the Southwest Fisheries Science Center since 2002 as a research oceanographer and is currently one of the lead authors of the NOAA Fisheries Ecosystem Status Report, part of the California Current Integrated Ecosystem Assessment Program. Dr. Jennifer Boldt is a research scientist at the Pacific Biological Station with Fisheries and Oceans Canada in Nanaimo. She leads a program on pelagic fish in the environment and conducts research and collaborates on integrative pelagic ecosystem monitoring surveys to understand biological and physical factors affecting the distribution, abundance, and trophic dynamics of pelagic fish and prey species. Her research also includes the use of advanced technologies and tools to monitor nearshore forage fish, ecosystem-based approaches to fisheries management, and state-of-the-ocean reporting. She is a co-chair and editor of DFO's annual State of the Pacific Ocean meeting and report. And Dr. Bridget Ferriss currently works at NOAA Fisheries Alaska Fisheries Science Center and works on various efforts to advance ecosystem-based fisheries management. She's the lead editor for the Gulf of Alaska Ecosystem Status Report, which is an annual synthesis of the status of Gulf of Alaska marine ecosystem that's communicated to the North Pacific Fisheries Management Council to inform their groundfish harvest planning setting process. So we have three speakers here who are uniquely knowledgeable about marine conditions in the ecosystems that they are responsible for. The plan for today is to hear about marine conditions now along the coast from north to south, beginning with Bridget, who will be talking about Alaska ecosystems, then Jennifer, who will be speaking to BC, and finally Andrew was speaking to California. And that will be followed by some observations on exceptional salmon returns in 2023 from Marisa Litz. After the presentations have concluded, there will be a short break, followed by a question and answer session moderated by Laurie Wykamp and Laurie Peterson. Please use the question and answer feature in this this Zoom presentation to pose your questions to the speaker at any time. If you're not putting a question into the Q&A feature, you can upvote the questions posed. And the moderators will choose the highest voting questions to pose to our speakers. If there are more questions that can be answered in the time available, we will try to get written responses from our speakers and include those responses in the seminar package that's produced after we finish this seminar. So thanks for your attention, and now on with the presentations. Over to you, Bridget.
All right, thank you very much. Just to check, you can see my first slide there?
We can.
Great. Okay, thank you again for the opportunity to present today. I was asked to present on 2023 marine conditions in Alaska, primarily the Bering Sea and Gulf of Alaska. And just to give you context on what I'll be talking about, as John mentioned, I am part of a team that produces annual reports to inform the groundfish fisheries by bringing in as much ecosystem information as we can into the fall discussions. And so we're kind of just at the beginning of collecting all this information right now. What I'll be showing you is really, there's not a lot of flow, but I tried to capture what I could of some of the data that we have received. It leans largely towards physical oceanography, but I do have some thoughts on how the ecology is shaping up. Our final reports with really a much more integrated synthesis are available online in December, and I have links for that at the end. Also, I'm part of this team of co-authors on the bottom here. I lead the Gulf of Alaska, and Dr. Elizabeth Siddon leads the Bering Sea, and Yvonne Ortiz for the Aleutian Islands, and also Stephanie Zador. And so these are all co-authors on the talk. And then finally, I'll mention all this information comes from other people who generously share it with us, and they gave me permission to share it today for this presentation. And so you'll see names at the top of each slide. Those are the PIs of the data I'm showing. Feel free to reach out to me if you'd like to follow up with them. I can pass on their contact information, or you might recognize some of the names. So here, this is our author list from last year's Gulf of Alaska status report. So again, lots of people contribute to these, some of which I'll be representing today, and the Bering Sea. Again, long lists of folks. So again, I do encourage you at the end to follow the links to our previous reports to get really a sense of the whole integrated system. And again, in December for this year. So here's a slide, really the take home of what I'll be talking about today. I'll start off with a couple of slides of the broad North Pacific and really looking at how we started off this winter in the third consecutive winter of La Nina conditions. La Nina often implies cooler sea surface temperatures, at least in Alaska, and that we're now transitioning. We are now in El Nino and transitioning probably to some more warmer sea surface temperatures next year. In the Bering Sea for 2023, we kind of have what we're starting to call a bit of an average year for temperatures and oceanographic conditions, not too dissimilar from last year. And that is in comparison to a big warm period that we had leading from the blob and all the way up through about 2020, 2021. Ecologically, last year, there was kind of mixed prey, thinking about what salmon might eat, zooplankton and forage fish, for example, in the pelagic system. It seemed enough to eat there, but there were some patches where there were lower zooplankton or higher, lower forage. But there was, it seemed like higher trophic levels were finding enough to eat in the system. 2023, still, as I said, data is still coming in, but it seems like at least lower in the food web. Primary production, zooplankton biomass seem to be a little, perhaps lower than average this year. So there might be a slight decline there. For the Gulf of Alaska, again, also kind of an average year, and we're happy with those right now. Again, coming off our third La Nina that helped bring the temperatures down after the warm period from 2014 to about 2019-20. So this year, again, also some perhaps less mixing, less transport, less movement in the system this year of water. And definitely watching to see how El Nino will manifest. That has more implications in the Gulf than in the Bering Sea. Ecologically speaking, last year, 2022, was a really pretty productive year in the Gulf as far as zooplankton, as far as forage fish. There was usually above average in a lot of the metrics that we collected. This year, as I'm just starting to get a sense of the data trickling in, I'm not certain. It seems like perhaps zooplankton might be a little bit below average, but there do seem to be a lot of forage fish, I think. So there might, again, be some mixed bags, but perhaps not as productive as last year. So that's the big high overview if you just want the one slide takeaway, but I'll walk through some of this now. Starting with some climate indices, and I'm just going to walk through a couple of these here, but these are some of the main ones that we talk about in the North Pacific. And starting at the top is the Nino 3.4. So that's the indices that's telling us if we're more of a La Nina or an El Nino period. And if it's below the line, that's La Nina. And again, the last 3 years, we've been in that phase. And June of this year, we kind of statistically entered a El Nino period now. We haven't seen up in Alaska yet really the warmer waters that sometimes associate with that, but that is forecast to arrive, at least moderate warming this coming winter, spring. Often when you see a strong El Nino, a stronger Aleutian low develops, and that is represented by the Northern Pacific Index in these indices, the green line, the third row down. A positive NPI index reflects a weaker Aleutian low, so it's been positive for the past 3 years, again, in line with La Nina conditions. You would expect, or often associated with a stronger El Nino, that line dips below, you get a negative NPI, which means a stronger Aleutian low. That hasn't happened yet. Same with often a Pacific decadal oscillation will respond positively with that strong Aleutian low. We haven't seen that yet either. That's still negative. So we're still seeing some of these indices reflecting perhaps the last 3 years of conditions. There might just be a time lag in response to this El Nino that's just forming. But also, while those are not in alignment, perhaps that could lead to a moderation of the impacts that we're seeing on perhaps sea surface temperature for the El Nino. So it's kind of waiting to see right now. It could just all still be developing and shifting from what we've been having from the past 3 years. And these are projections for sea surface temperature for the upcoming fall. So October to December is the top plot. That's a map of the North Pacific with North America on the right-hand side. The land is in white. And so the reds are warmer color, are warmer temperatures, anomalies, and white is more neutral. And so this is what's forecast for the upcoming fall on the top, and then December to February, winter in the middle, and then February to April, next spring on the bottom. And this is based on an average of 8 different climate models that are forecasting forward. And in general, again, you can see the El Nino, that's the big dark red colors along the tropical Pacific. That's definitely there. By next spring, you can see some red colors coming up along the coast. Up in Alaska, since that's my perspective here, we see some whites and yellows, so some average to moderate warming forecast up there. But also as a caveat, the baseline for these anomalies that the temperature is being projected is actually a pretty warm baseline. It's 1991 to 2020. That includes a lot of those heat wave years. So for something to really show up red, it has to actually be pretty warm. So I think we are projecting warm sea surface temperature up in Alaska, perhaps just moderate. Again, a little bit of a wait and see. And so now I'll just show a few slides for the Eastern Bering Sea and then the Gulf of Alaska. So here's the map to orient you of Alaska, and I'm talking about the white shaded part there, which is mainly the shelf region. And these, again, temperature, but these are satellite-derived sea surface temperature just for 2023. Well, actually, no, September 2022 through to current September right now. And these are divided, the Eastern Bering Sea is divided. The columns are the outer domain, middle domain, and inner domain. The outer is the deepest, so 100 to 200 meters. The middle is 50 to 100 meters, and inner is more coastal. and the northern Bering Sea on the top and the southeast Bering Sea on the bottom, divided at 60 north. And the 2023 is the blue line, daily average sea surface temperatures. The purple is the long-term mean from 1986 to 2016. And then you have daily averages on all the other years in gray. And so the main point here is the blue line pretty much falls on the purple line. So we're seeing pretty much average, if you compare to this time series, of temperatures in the Bering Sea, except the red circles where we had a little warmer than average. So that was this winter for the more deeper outer domains in both the northern and southern Bering Sea, and also in the middle domain in the southern Bering Sea. Now that did not trigger the statistical marine heat wave threshold of being warmer than the 90th percentile of temperatures for a given day for 5 consecutive days. So it was warmer, didn't trigger that kind of marine heat wave, which in the Bering Sea, that temperature is high enough to trigger that marine heat wave threshold, have been brief and infrequent since about 2021. So we've had some temperature fluctuations, but not extreme. Sea ice is a big story and driver of a lot of ecology in the Bering Sea, and that's driven primarily by temperature and wind. And so this is a plot of sea ice extent, so how far south pretty much, and the expansion of sea ice in the Bering Sea each winter. And so it's measured in kilometers squared. And it's a timeline on the x-axis from November to July. So really the middle of winter is the top of the curve there. And you have sea ice building up on the left-hand side and then melting on the right-hand side. And the blue line is this past winter, 22, 23. The green line is the winter before that, and the black solid line is the long-term median. And so one note this year is we had a 1-month delayed freeze up of ice. And so the blue line is shifted to the right of the green line. And it was also 1-month delayed melting in the spring. And so really that was due to in the fall, we had stormy weather. There was a slow freeze up in the Chukchi, and the big typhoon Merbok that hit Alaska last fall brought warm water and a lot of mixing. So that delayed the freeze up of ice. And then cold temperatures in the spring delayed the melt out in the spring. Maximum sea ice extent occurred February 17th, the peak of how broad the sea ice extent was. And that's about a month earlier than the long-term mean, which is more March, middle of March. So it has generally moved earlier. Right, and then, so cold pool is another big metric for the Bering Sea. This is the temperature of waters, the bottom waters on the Bering Sea shelf related to sea ice extent. And this is temperatures below 2 degrees in the bottom waters. And that's what's shown in the blue colors here. And these are all different years of the extent of the cold pool. 2023 is the bottom right-hand plot. And the significance of this cold pool is a few things, but one is it really can influence the distribution of a lot of at least the ground fish in the Bering Sea. It can be a thermal barrier. Some fish can go in there and some just stay outside of that cold pool. And so you can see some fluctuations, for example, 2018 and 2019, where really we had a lack of sea ice in those years. It was warm, and you can see really not much of a cold pool. So a lot of species moved north those years because there was no thermal barrier. 2023 is looking pretty average, similar to last year, and a slight cold tongue coming down south, bringing some colder bottom waters. You can kind of see an extension down to the southeast there. But again, kind of in an average space in the Bering Sea. And this is my Bering Sea summary. Again, what I said, again, a little bit of an average year temperature-wise. No marine heat waves are infrequent since 2021. Sea ice, it was shifted 1 month later, delayed freeze up and melt out. I didn't show ice thickness, another measure of sea ice, but that was actually thicker, above average, north of St. Matthew Island. And then the cold pool, again, extent was somewhat average, similar to last year. I have ecological conditions listed at the bottom, and I haven't shown you any plots. We're actually just starting to see some this week, but it does look Like I said at the beginning, there are some indications, at least phytoplankton, zooplankton wise, of lower production at the base of the food web this year. Some of our zooplankton surveys are showing lower biomass. Some of our satellite data that shows that plankton blooms are showing lower spring blooms. But that's not the final answer. That's only part of the data we're receiving. So to be determined, but that's just a preliminary look, which we were asked for today. So take that with a grain of salt. And then Gulf of Alaska. Again, the sea surface temperature, this is from satellite derived data. And this is just 2023. So starting in December, moving through December, but the black line is 2023. So that ends in September, pretty much this month. And again, the same as the Bering Sea, we're in an average space right now, largely, or perhaps a little cooler. You can see the black line falls directly on the purple line, more or less. And the blue line is last year. And you can see there was a warmer summer, the blue line, both in the Western Gulf and the Eastern Gulf of Alaska in the summer and in the fall last year. This year, we did have a peak in the Eastern Gulf of Alaska in July, August, a warm peak, I think primarily just due to some stratification and not a lot of storms mixing, and it got warm. It did cross that marine heat wave threshold briefly, covered about 50% of the Eastern Gulf shelf, but it was brief enough that I wouldn't suspect major ecological implications from that. So overall, again, kind of average temperatures, our fourth consecutive year of no persistent marine heat wave conditions. And that's the temperature. I do have a little bit of prey data that I'll show, I know more relevant to salmon, some zooplankton, and some herring. And I'll point out that these are data from our Southeast Coastal Monitoring Survey that does receive funding from the Pacific Salmon Commission. And the amazing part of this survey finished in August, and I have 2 slides of data from them already that I just received yesterday. And so they just turn around the data so fast that we can get it into our kind of fisheries management system, which is amazing to me. But these are inside waters in Southeast Alaska. So not always necessarily reflecting the broader shelf ecosystem. But it's a great time series, and it does show from 1997 to 2023. So the farthest right point is 2023, this summer. And you took the top plot. This is total zooplankton, kind of adding up all the species you see here, plus a few more in that area. Kind of, you can think of it as a biomass of really how much zooplankton's out there. And you can see it's dropped below the average this year from a pretty high peak last year. So like I said, last year was a pretty productive, it seemed, in the Gulf. This year, at least with this data set and perhaps a few others, we're seeing less zooplankton, with an exception of large calanoid copepods, which is the third plot down. That's still above 1 standard deviation above average. And those are nutritious, more of the high lipid copepods. So that's good news. But euphausids, the one above it, is down, which are important prey, and just in general, less zooplankton. So that's one piece of news. In that same survey, they do measure juvenile salmon. So length anomalies on the left. So are they kind of longer or shorter relative to average? And then on the right, energy. So their actual energy content, which is related to how much nutritious food are they getting, lipid storage for the upcoming winter, you could think of it as. And so these are by the different species. In general, looking at the length anomalies on the left, that 2023 point, the farthest point in the time series to the right, is below average again this year. So you can see pink salmon declined, chum salmon declined, sockeye actually maybe increased a bit, right around average, and coho declined. So not as large length. There's ways of interpreting this, but in general, you want to build up energy and you want to build up size going into that first winter. So perhaps they're not all, some of them are closer to the average, but some of them are declined this year. Looking at energy densities, pink salmon really sticks out, as not only are they smaller, but they have a lot less of that kind of energy storage and also sockeye salmon. The third one down on the right also has a decline below average. I was told also pink salmon that their diets this year, again, these are juveniles, they're eating a lot more gelatinous larvaceans, which would be less nutritional quality. So that could be leading to this lower energy density. So again, juveniles, which I know might not impact your in-season management this year, but of note. And then finally, herring. This is again in Southeast Alaska. 2 spawning stocks, the purple and the orange line, 2 different stocks in Sitka and Craig, which are Southeast Alaska, but on kind of the shelf ocean side. The forecast for 2023, they do show a decline, but actually this is still pretty good news in the context of what's happening here. There was a really large herring year class in 2016, and they entered the spawning stock biomass after about age 3, so 2019, where you see these giant peaks. So there was just a big gush of age 3 herring in 2019, and we're just starting to see that year class slowly disappear from the population, so that's the decline. But this is still higher than most of the time series, so there's still, relatively speaking, a lot of herring in Southeast Alaska relative to this time series, and there is reason to believe there's another year class coming up behind them. Similar in Prince William Sound, I'm not showing it here, but they also benefited from that large year class of herring and continue actually to have a little rise in their population. So to finish off for Gulf of Alaska, we have a continued multi-year period of similar, somewhat average ocean conditions from last year. We're waiting to see if there'll be some warmth next year with El Nino. But we've had a few years of non-persistent marine heat wave conditions that have helped us, the system reset after the marine heat wave years of 2014 to 19. Ecologically speaking, again, still a lot to be determined, but we do see some lower total zooplankton biomass in Southeast Alaska, except for elevated large copepods. And herring, while reduced, still seem in the system. And I have just been hearing that there's also a lot of capelin in the system. So perhaps we are seeing good forage fish. I'm not sure about the zooplankton populations yet. And so I'll end it there. As I said, a little bit scattered on what data I could present to you, but that's what I have right now. And those are my same key messages. And then finally, at the end of the slide are where you can find our reports, and a better version of this story will be in December. And please feel free to reach out to any of us. Thank you. And maybe I'm handing it off to, I'm not sure, to John or to Jennifer now.
Yeah, Jennifer is the next speaker in the order of presentation.
Great, thank you. Let's see if I can. I'm going to see if I could share my screen. However, my sharing screen button has disappeared. Interesting, never had that.
If you hover over the bottom of the screen, then mine appears again.
Huh. Ah, yeah, it shows up again. Thank you, Bridget. All right, so hopefully you can see my slides.
We can.
Perfect. Thank you. Well, thanks for having me. I'd like to start by acknowledging that I'm joining you from the traditional and ancestral territory of the Nunamic First Nation, who are past, present, and future caretakers of this area in Nanaimo, or what we call Nanaimo. And I have assembled information from DFO's annual State of the Pacific Ocean report and meetings, or we call them SOPO reports, State of the Pacific Ocean reports. And I've done that with the help of many other people, in particular. Let's see, meter view. All right. So hopefully my slides are advancing for you as well. If not, just say something, but I'll proceed as per normal. But Jackie King, Chris Neville, Sue Grant, and Strawn Tucker helped me a lot with this presentation. And then there's a lot of people that have contributed information to the State of the Ocean report, which I borrowed, and they said I could borrow. But there's a lot more contributors to this SOPO report, and they're all listed. If you go to that QR code, which I'll show again at the end, you can get to the latest report that we've published and all the contacts for this kind of information. And so similar to Bridget, thankfully we agreed that she would present a large scale climate indicators. So thanks for doing that, Bridget. Because that applies to the broad scale Northeast Pacific Basin. And the information I've put together from the State of the Ocean reports today is, we don't have a lot of information on 2023, but we do have a tiny bit. And we're on a different schedule than the Alaska Center's Ecosystem Considerations report. So we are just finished publishing our report on 2022, and we're just starting to organize our meeting for the 2023 conditions. So we just have a tiny bit, but I think I can provide some context for the conditions that the salmon that are returning this year must have experienced during their life history. And so the State of the Pacific Ocean report is not specific to salmon, but it does have a lot of information that is pertinent to salmon. So there's information on the freshwater habitat that they experienced, also a lot of information on the physical marine habitat, as well as their prey and their predators. And we have time series of salmon themselves in the report. And as you know better than I do, there are 5 species that DFO manages and studies, and they spend part of their life in freshwater and part of their life in saltwater, and the time that they spend in each of those varies depending on the species and life history strategy. And so the information I'll show is primarily marine, but a little bit of freshwater time period as well. So the salmon that are returning this year would have experienced conditions in freshwater environment in 2018 through 2021, depending on, again, their species and life history strategy. And as you know, the things that can affect the habitat in the freshwater environment are things like precipitation, air temperature, snowfall, etc. And we have a lot of that in the report, but I'll only show 2 things. And the first one is this spring air temperature anomalies. So these show the spring air temperature anomalies in British Columbia from 2018 through 2022. And the warmer colors indicate warmer than average temperature for different snow basins within British Columbia. And you can see that 2018 and 2019 were warm years, whereas 2020 through 2022 were typically average years overall, except for keep in mind that 2021 was the deadly heat dome year. And then if you look at drought conditions in BC, it paints a little bit of a different picture. Don't worry about reading all the tiny font on the screen, but I just took screenshots of the drought conditions in British Columbia for 2018 through 2023. And once you get in, the rows all represent different snow basins within British Columbia, and the columns are months within each of the years from about June to October, November. And you can see that once you get into the orange and reds and browns, the adverse impacts from droughts are possible, likely, or almost certain as you get into the brown colors. And it's quite striking that the change that's been seen over the last 6 years. There was some drought in 2018 and 19, but 2021, 2022 stood out as drought conditions that would have almost certain impacts on ecosystems. And then 2023, we've seen unprecedented drought in British Columbia. And so for salmon returning in 2023, they would have experienced marine ocean conditions from 2020 to current times, and in this broad Northeast Pacific area, depending on species and life history strategy. And what we're seeing in British Columbia is a long-term increase in sea surface temperature anomalies. This shows a graph of temperature anomalies that are recorded at BC shore stations and have been recorded since 1935. And the red color shows that temperatures have been above average in the last decade or so. And then we see this long-term linear increase of about 0.9 degrees Celsius per 100 years. And then since the marine blob, or the 2014 through 2016 marine heat wave. We've had other marine heat waves come through the system. So in the upper left 4-pane plot there, that shows the 4 seasons of sea surface temperature anomalies in 2020. And for most of 2020, we were in marine heat wave conditions. In the upper right, you can see sea surface temperature anomalies for 2021. And I just show the overall for the whole year because that was a normal year, but that was despite having a La Nina and negative PDO conditions, as Bridget showed us. That should have led to abnormally cool conditions, but we had actually an average temperature year. And in the lower left, those are anomalies for 2022. And again, overall, the year was normal, although we did have a brief marine heat wave in the summer. And then on the lower right, that's conditions, that's a snapshot I took from NOAA's webpage that shows the marine heat wave that had occurred in 2023, and which we're going to hear about more later from Andrew. And heat waves can affect more than just surface waters. This plot shows the temperature anomalies at Ocean Station Papa, which is out in the middle of the Northeast Pacific there, at the end of one of our transects that we monitor regularly called Line P. And this shows temperature anomalies with depth from 2001 to early 2023. And the red colors indicate that there were above average temperatures at all depths during that marine heat wave blob of 2014 through 16. We also had elevated temperatures in 2019 and 20. And again, we've had this brief marine heat wave in 2022. As we have changes in temperature and currents and transport, we have changes in ocean stratification. And so that affects the vertical mixing of nutrients into the upper part of the water column. And we need the nutrients to get to the upper part of the water column so that phytoplankton can use them. And then it moves up through the food chain after that. So this plot shows at the same station, Ocean Station Papa in winter, it shows the isopycnals or density of the water column, again from 2020 or 2001 through 2023. And what happened during the blob was we had strong stratification, reduced vertical mixing, and so fewer nutrients made it to the surface. And you can tell, it's hard to tell on this graph, but the turquoise colors didn't make it to the top of the graph, essentially. So the isopycnals weren't reaching the surface of the water column. We had similar conditions of reduced vertical mixing in 2019 and 20. And then since then, we've had, it appears to be more normal mixing into the surface waters. And so then moving up the food chain, we know that zooplankton are prey for juvenile salmon, but also some adult salmon like pink salmon. And I know you've heard this before, that there's a distinction between boreal copepods and northern copepods, which tend to be larger, have a more lipid-rich body, and so are better prey quality for salmon, versus southern copepods, which tend to be smaller and are lipid poor compared to the northern counterparts. And during that marine heat wave of 2014 through 16, there was increase in the number of small lipid poor copepods on the Vancouver Island continental shelf and in the shelves of other areas of British Columbia, and then a reduction in the more lipid-rich copepods. But as of 2022, anyways, it appears that the community composition has gone back to more of a normal composition where we've got average amounts of southern copepods and above average or near average amounts of boreal and northern copepods. In the Strait of Georgia, we don't have typically the oscillation or the distinction between the northern and southern copepods. Rather, Kelly Young and others monitor the total zooplankton and then also some zooplankton that are prey for juvenile salmon. And the total zooplankton in the Strait of Georgia, they've been anomalously high, or biomass has been anomalously high in the last 5 years, as has been the typical zooplankton that feed juvenile salmon, which are amphipods and decapod larvae and euphausids. The Strait of Georgia is also the area where a lot of salmon from the Fraser River will come and enter the ocean environment, and salmon like juvenile Chinook and juvenile coho will eat juvenile herring and anchovy. And we do have an age 0 or juvenile herring survey in the Strait of Georgia every fall. And the index of abundance from that survey has shown that the abundance of H0 herring has been below average since about 2012. That's shown on the left plot, and the horizontal line is the average abundance index. And in that survey, we also incidentally catch northern anchovy in our sets, and the proportion of sets where we're seeing northern anchovy appear has increased over time. Particularly, it was high in 2016 through 18, and also in 21 and 22. And then herring are also herring of all sizes and ages are prey for adult coho and chinook. And we have a survey of the pelagic ecosystem on the Vancouver Island continental shelf in the summertime. And the maps on the right show the distribution and biomass of herring in the summer from 2006 through 2022. And we used a spatial temporal model to estimate biomass from the survey, which is shown on the left. And what we've seen is an increase in biomass of herring over time in this area, particularly off the southwest coast of Vancouver Island. And this is sorry, I can't write the right word. It also agrees with what's being seen in the stock assessment of herring, where they are seeing a coastwide increase in the biomass of spawning herring. That depends on the area that you're looking at. Different stocks have different trends, and Strait of Georgia stock is primarily, I'd say, the one that's responsible for this increase in coastwide biomass of spawning herring that we're seeing. And the main migratory stock of Strait of Georgia herring forage off the southwest coast of Vancouver Island in the summer. So what we're seeing in the survey is mixed stocks and mixed stages of herring. As for some of the predators of salmon, groundfish are known predators of salmon. There was a study by Pearsall and Fargo a while ago that showed that, for example, petrale sole and lingcod eat chum, sockeye, and pink salmon, and dogfish can eat coho salmon. And so DFO has surveys of groundfish in all areas of BC, and I've just picked out a couple of trends from their survey estimates. And they have shown that some of the groundfish have increased over time, like petrale sole, which is on the left, and lingcod, which is in the middle, whereas other groundfish, like spiny dogfish, have declined in all areas that have been surveyed, which is shown on the right. So a mixed trends in terms of groundfish predators. We also know that pinnipeds eat salmon. So for example, harbor seals and California sea lions. And for harbor seals in 2015 through 19, about 90% of British Columbia's coasts were surveyed for harbor seals, and they estimated about 85 to 90,000 animals in British Columbia, and that the population is either stable or declining. And for California sea lions, that population off the US West Coast was assessed in 2014 and estimated that there was about 257,000 animals there, and that population is sort of stabilized. Those animals come to BC in the winter, and they're counted in winter haul-out sites. And there was a significant increase in the number hauling out between 2009 and 2017, but not in the most recent survey in 2021. There's also been changes to the whale populations in British Columbia. We know that some are recovering and some aren't. So the southern resident killer whales, which are the salmon eaters, they're endangered. Northern resident killer whales, their mean population rate has grown at about 2% per year, but they're considered threatened. The bigs or transient killer whales, their population is increasing at about 4% per year, and their sightings of them have increased in the Sailor Sea, coincident with their main prey, which is harbor seals. And then we know humpback whales have continued to recover from past exploitation, and they're reoccupying areas of BC. So that's it for physical and biological variables that may have affected salmon that are returning this year. But we also have a time series on salmon themselves. We have juvenile salmon surveys on the Vancouver Island continental shelf in the summer, which is the left column of graphs, and then also in the fall, which is on the right column of graphs. And the salmon encountered in these juvenile surveys will spawn at different times, and they'll return at different times depending on which species and life history type you're looking at. Again, these indices of abundance are estimated through a spatial temporal model. And so we can estimate abundance when we didn't have a survey, for example, during COVID in 2020. But we can look at a couple examples. For example, pink salmon that are returning in 2023, the index of abundance for juveniles was above average, and those fish were fatter than average. So you'd expect perhaps above average returns of those fish. Same for coho. Those fish, index of abundance was near average. So perhaps expecting a near average return for coho this year. Looking forward, Chinook salmon that were sampled in 2021 as juveniles, those ones would be expected to return in 2024, and their index of abundance was below average, so perhaps their returns will be below average. Same for sockeye, they were both below average in the 2022 survey, so you could potentially expect below average returns for those. We also have juvenile salmon surveys in the Strait of Georgia, and typically those occur in June and September, although in 2022, only the September survey was able to be carried out. And again, depending on what species you're looking at and what survey year, you can get an idea of what you might expect in terms of salmon returns. And just as one example, pink salmon that were sampled in 2022 were above average in terms of their abundance. And so you'd expect above average returns this year. And sockeye salmon that were sampled in 2022 in the fall were below average, and perhaps so you'd expect a below average return. Those, again, it depends on which stock you're looking at, but those ones that are sampled in September are typically Harrison River stocks. And then Stephen Latham, who's with the PSC, has looked at Fraser River sockeye salmon sizes. And what he's found was that there's been a decline in the overall size and age of Fraser River sockeye, and that there's been this biennial fluctuation in which sockeye tend to be smaller, shorter, skinnier, and lighter in odd numbered years. And so on the left hand panel or graph, that shows the weight anomalies of the even numbered years fish in purple, and then the odd numbered year fish in orange. And so you can see this decline over time and difference between even and odd numbered years. And then he's also looked at condition of fish on the right plot. And again, there's this difference between even and odd numbered years, where the odd numbered years fish tend to be skinnier and lighter over time. And then you've probably seen this graph where shows the Canadian catch of salmon over time has decreased over the recent decades, primarily due to changes in target populations, but also due to management actions. And the returns in 2019 through 21 have been low, and that's led to really low Canadian catches. So with that, I'll leave you with this infographic from our National State of the Ocean report, when the QR code for that one is on the right, and our SOPO report QR code is on the left. And we do consider that climate change is a dominant pressure acting on the Northeast Pacific, and it affects the physical and biological environment that the salmon experience. So with that, I will pass on to the next speaker. Thanks. Hi, Chika.
Hi, thanks. I'm the next speaker, Andy Leising. Give me just a second to start sharing my screen.
You're muted.
Great, now can you hear me?
Yep.
Excellent. Okay, so let me get right into it. I work with a team that puts together a similar kind of report, a yearly report on the conditions throughout, really not just California, but the whole, what we call the California current. However, we don't deliver our report to our Fisheries Council until March of the following year. So we really haven't compiled almost any of that data yet. But instead, folks asked me to come here and talk more specifically about what happened with marine heat waves this year, and I'll also give a little context for the last couple of years. So right off the bat, here's the picture, the latest imagery of sea surface temperature taken from satellite. And you can see that dark red area that's encircled by a sort of black line. That is the current heat wave as of only a few days ago. And it's been building strength all year. And I'll talk a little bit more about that. First, just so we're all on the same page, someone earlier actually said exactly the definition, but I included it here. A heat wave is defined as temperatures where it's greater than 90% of all the measurements for that spot for that day of the year, and they have to last for over days. And so that definition comes from a paper from 2016. And it's based on atmospheric definitions of what an atmospheric heat wave would be like. And again, here's a picture of this most recent heat wave this year. This was at its maximum size. At this point, this is covering roughly 6 million kilometers squared in area. And you can see it's actually most of the Washington, Oregon coast and all the way up through Canada into part of Alaska. So it was quite big and covered quite a bit of the ocean only a couple weeks ago, and it's actually still out there. So for the California current, why do we care so much about these heat waves and why in general we care about them? Well, most of you may know this, but I'll just go through it again. Typically when the heat waves come in, they're a pretty good indicator of usually there's lower productivity along the coastline. It usually disrupts the food web. We know from the 2016, 2014 event, the blob, that it changed the plankton. So as was just mentioned, it often changes what the copepods are that's out there. So they're less tasty and less fatty. For Washington and Oregon, a lot of times these heat waves are followed by production of harmful algal blooms that produce domoic acid, and that leads to shellfish closures. I'm not sure that's a big problem for salmon, but it does definitely wreaks havoc on the shell fisheries. It also leads to deaths in marine mammals and strandings. One of the other things that happens quite often is there's this compression of the habitat in the sort of east-west direction. And so that leads to more, basically more marine mammals and whales tend to be closer to the shore, and that leads to more entanglements and ship strikes. So that leads to problems. And the other thing that happens is we tend to notice changes in the ranges of other fish. So the fish that can will shift their distributions north, and this will definitely disrupt some of the food web dynamics. So how does this year so far stack up compared to history? So we essentially have pretty good history from satellite records back to about 1982. So what I'm showing here is all the what I call sort of large marine heat waves that have occurred since that time. And I've been able to track about 218 distinct events in those roughly 40 years. So you notice I've labeled on here the blob, and that actually began in 2013, and that was essentially the largest and longest heat wave we've had in this period. But you notice some other notable things on here. 2022 was actually lasted more than a year, and it was basically the 5th largest heat wave. And right now, even though it's kind of still in its relative infancy, the 2023 event has reached a size of basically over about 7 million kilometers square at one point, making it essentially the 4th largest heat wave. So this is a pretty unusual event, and it's rivaling basically Blob 2.0 that was the 2019 event. And you can also see actually 2020 at one point had a heat wave that was quite large. So this is quite an unusual event that we're having this year compared to the bulk of the heat waves of the past. So I say it's unusual, but really it's actually not that unusual if we just look at the last 10 years. So here's the tracks of heat waves from of sampling of years 2014, 19, 20, 21, 22, and 23. Basically how big these heat waves are as a function of what day of the year it is. And you can see they all kind of follow this similar track. Essentially, these heat waves are kind of born far out to the western edge of the map. That's the map in the lower left. So they basically kind of rise up in the early spring, late winter. Then they kind of, during the year, they kind of hang out way offshore. And then essentially they grow up to these massive sizes sometime in late September or late August to September. And then they tend to, during the fall months, they'll recede away back from shore, back to the sort of their birthing grounds offshore again. And that's seems to be this repeated cycle that we're having year after year now. Basically, since 2019, we've had this pattern every single year. What's different really between the years is how much they get into the coastal region. So for my purposes, we look a lot at basically the exclusive economic zone. That's the little region I have in the map in the lower right that's outlined by the little blue dash. So that's the EEZ. So the top graph is, again, just how big the heat waves are across the entire Northeast Pacific. But the bottom graph here is showing what percentage of that sort of blue hatched area is filled by heat wave. And so you'll notice that's really what's different. So the top graph, they're all about the same. They have the same sort of phenology. But in the bottom graph, what's important to the coastal regions and a lot of the fisheries is how much of these heat waves actually get into that coastal region. And so you see that it's quite variable year to year. You'll see 2023, it actually ended up having sort of a later impact, but a sort of in a way kind of a stronger, more consistent impact during this later period of the summer. But you'll notice that most of these heat waves, once they reach their peak, they kind of go away and leave the coastal zone, except for the notable 2014, of course, that was the blob, and it ended up essentially through the fall covering almost 100% of that EEZ. So just looking in more detail as to how this year kind of panned out. Again, this is just a bar plot of how big the total heat wave was over time. But I've color coded it now as to how much of the EEZ it is covered. So you'll notice that it starting around August, it was 25 to 50%. And then sometime towards the end of August, it actually started covering over 50% of the region. And this is just another look at the same data, just sort of showing the sort of spatial distribution here. So you'll notice there was this little blip of heat wave that came in May up in Washington and Oregon, actually. But then towards the end of the year or the last couple months, it's really most of this heat wave action has been off of the Oregon and Washington coasts. That's sort of region 1 and 2 I'm showing here. So you can see when that came in. It's mostly up in that northern part of the California current that we've had these heat waves come in this year. Something I always get asked is it's important to understand the difference here between heat waves are defined by their anomaly, so how much warmer they are than average. But people often care about absolute temperatures because, you know, for some of these animals, the animals, it really matters what the absolute temperature is. So just to give you an idea of how warm these heat waves tend to be, that's what I've kind of plotted on here was basically the absolute temperature of these various heat waves over time. So you can see I've pointed an arrow towards what 2023 is, and at its warmest, it's only about, say, 18 degrees, versus El Niños tend to actually be a little bit warmer. They can be up to, they've in the past, like the 97, 98 El Nino, they're actually a warmer event. So in a way, those are actually a more intense kind of heat wave than these current heat waves. What's interesting to note too is during the blob years, the 2014 to 16, you can get heat waves in the middle of the winter, but they're not really that hot. These are heat waves that are only 12 to 13 degrees. But again, it's based on the anomaly. So it's a difference from normal. So these were still times when the water temperatures were 1 degree to 2 degrees warmer than they normally would be at that time of year. However, the water temperature, in an absolute sense, is actually kind of cold. So just to give you a little sense of why it's different in the different years, even though the heat waves on the offshore are similar year to year, these last few years, what is causing them to either be in the coastal region or not in the coastal region to a greater or lesser extent? And it all has to do with the wind patterns. So essentially what happens is we get these low pressure centers. So on the graph on the left, you can see I've circled what would be an atmospheric low pressure system. And these low pressure systems, it's important to remember that in the northern hemisphere, wind will circulate counterclockwise around a low pressure system. And so the wind on the eastern side of the low pressure system, I know this is a lot to follow, will be heading north. And that's that yellow arrow heading north on the graph on the left. What happens, though, is that these low pressure systems tend to track from the west towards the east, towards the coastline. And as they do, it transitions to this picture on the right, where we have a change in winds along the coast. So instead of the nice southward blowing wind, which causes upwelling and cooling and all the good plankton productivity, instead we get winds that blow towards the north, which causes the exact opposite, downwelling, a warming of the surface layers, and a suppression of productivity. And so it's essentially the history of how many of these low pressure systems work their way across the region that's affecting how much warming and how many heat waves we actually end up getting into the coastal area from year to year. And just to show a little bit more quantitatively that relationship, this is essentially a correlation between the sea level pressure, the atmospheric sea level pressure around the Gulf of Alaska region versus the north-south winds along the Oregon-Washington coast. And there's actually a pretty great correlation between these two things. Interestingly enough, there's a slightly different and significantly different relationship for off the coast of California. So it affects these two areas a little bit differently, these pressure to wind relationships. Another just example, there's a lot of things on here. I don't want you to look at all of them. Just to say that this is just to point out that in turn, those north-south winds are actually quite well correlated to the temperatures along the coast, and that's the two scatter plots sort of towards the right of this. There's a significant correlation, but they're typically lagged by 2 to 3 days. So the water warms up 2 to 3 days after the wind changes. And this sort of line plot on the left is essentially showing that if you happen to have a heat wave in the offshore region, which is the green line on this graph, and you then have a reversal in the winds, which is the blue line, as soon as the blue line goes above zero, it drags all that heat wave that's offshore into the nearshore region. And that's pretty much the whole takeaway from this plot. I know it's a lot. So essentially, I know this is really quick, but just that's what I wanted to get across to you is what the heat waves have been like and what's driving these coastal influences. This is a summary of all of what I've said. So essentially, we've had these offshore large heat waves nearly every year since 2014, and especially the last 5 years, they've followed almost the same sort of phenology. These heat waves have differential coastal impacts, again, depending on these low pressure cells that change the wind patterns in the coast. More specifically to 2023, this was a pretty unusual event. It's the fourth largest by area since we've been able to have these measurements since 1982. It's very similar to the past 4 years. It had less intrusion in the midsummer, but more intrusion in the later part of the summer this year into the coastal regions. Most of these intrusions were in the Washington, Oregon coastal region, but there was actually some significant intrusions into California later in the summer. The short-term forecast right now suggests that there will be additional warming over the next week. So this is very short-term forecast based on the wind forecast. So I expect those waters to actually warm back up for a week or two, and then it's difficult to forecast after that what will happen actually. The models are not that good if you go past a week or so. So this leaves us with the final question here of what is actually going to happen this fall. We essentially have sort of two choices. One would be that the heat wave recedes to the far offshore during fall, which is what has happened over the last 5 years, to be replaced by probably normal, sort of normalish water temperature until we have our spring El Nino roll in. But there's always the possibility of the second choice, which is that the heat wave might remain with some of its persistence related to the El Nino drivers. And that could then cause an additive effect with the spring El Nino, leading to really warm waters across the entire Northeast Pacific. And of course, since we really don't have too many observations of both large El Ninos plus large heat waves, there's always a possibility of other. The most recent forecast I've actually heard, as recent as just yesterday, suggests that option number one is the most likely, that the heat wave will likely retract to be replaced by somewhat normal waters through most of the system, followed by that spring El Nino. And just making a shameless plug, most of the graphs and daily and weekly updates of heat wave action in the Northeast Pacific you can find at our IEA website under the name Bob Checker, and there's the QR code for it. And that's all I have. Thank you.
All right, and so I'm going to close us off with just a few observations from around the North Pacific on salmon returns in 2023, kind of as a result of many of these marine conditions that we've seen in the last few years. And coming off of the three-peat La Nina, which is generally favorable for salmon returns as we transition into the El Nino. So first up is moving from north to south. So the Alaska commercial harvest. So this year, 2023, is shaping up to be 26 million fish above the preseason forecast. And this is really due to strong chum and odd-year pink returns in areas like Prince William Sound, Southeast Alaska. And this includes all species as well, Chinook, chum, and coho. And then what it looks like in terms of sort of the longer term average, so this plot is 1985 through 2023, is that one of the top 10 returns for commercial Alaskan harvest. And then inset in this graph too is the Bristol Bay commercial catch, and it looks like the record-setting Bristol Bay return of 2022 was not achieved in 2023, so slightly lower, about 50 million, which is about forecast, but not as big as last year. Okay, next up, we have the Fraser River. Again, here we had an unexpected strong odd-year pink run. So the initial forecast was 6.1 million, but in season it was first upped to about 20 million. And then more recently, in the last couple of weeks, it downgraded to a 15 million. So in the time series, again, going back to 1985, showing sockeye in purple and the pink returns in pink. And then the returns to date as of sort of last week. So that's 1.5 million sockeye and 6.8 million pinks. But if the pink run does come in as it's been adopted in season at 15 million, that's going to really bump those 2023 numbers up. You're going to see one of the largest pink returns in over a decade. And then inset in this figure here, we also have the 2023 river temperature in Fraser River. As Jennifer mentioned, most of BC has been in a drought in 2023. And so what you have is in the green line are the current observations of river temperature in the Fraser, and that trends above that median value that's shown in the black straight line, and kind of dips above some of the maximum observed temperatures in the 1991 through 2020 average. Throughout BC, we're also seeing strong sockeye returns, or relatively strong sockeye returns to the Skeena, as well as pink returns there. And then the Columbia River, so these are returns to Bonneville Dam as of today, or yesterday, I should say. Again, above forecast due to strong Chinook, sockeye, and coho returns. And so just might be noted that the coho were really at the early part of the return, but we're already among the top 5 runs, both for Chinook and for coho of the 10-year average. So fall Chinook and coho are going to be continuing to return to the river over the next 2 months, and they're already both the run sizes are within the top 10. So that's encouraging. So we have currently the return of all species is sitting at 1.1 million. And then similarly to what we had for the Fraser is the 2023 river temperature at Bonneville. It's above, that's shown in red, and it's sitting above that 1976 through 2022 average. So again, yeah, high return of sockeye, about 300,000. And then the Chinook, like I said, sitting at 105, but we still have many, or sorry, I switched steelhead and Chinook in this figure. So Chinook is actually 643 and the steelhead is 105, but we still have a couple months of returns. And then lastly, so the Puget Sound and the Washington coast. So some notable returns there, and on display from this excited angler is the highest run of Baker Lake sockeye, coming in at about 65,000. And that doesn't sound like much, but considering there were less than 100 fish that returned in 1985, it is pretty astounding the comeback of that fish, of sockeye to Baker Lake. What we're seeing coastally are high CPUEs for Chinook and coho in marine areas, including the coast. But currently, Washington is also experiencing drought conditions. Coho harvest is lagging about 40% below model expectations in the Queets and the Quinault. And these low flow conditions are really affecting coastal rivers. So while we're seeing high CPUEs of Chinook and coho, we're seeing it from Alaska through the straits, coastally in Oregon and Washington and in Puget Sound. Interestingly, Alaska is seeing smaller body-sized coho, whereas there was concern that coho body size was small earlier in the summer, but they're returning to more normal sized in the Straits and Puget Sound. But there really is some concern about the low flow conditions and returns of coho in coastals. And then, as always, as Andrew mentioned, during an El Nino, there tends to be a propensity for some subtropical and tropical species to move north. And we've seen that off Washington. So a state record was achieved for the mahi-mahi catch off of West Fort Washington. And then earlier this year, a bluefin tuna washed up on Orcas Island. So, and I don't have an exciting QR code, but those are the hot off the presses salmon returns for 2023.
Great. Thank you, Marisa, for that. And thank you to all the speakers. That was really fantastic. It was wonderful. In the interest of time, normally we take a break now, but we're running a little late. So we're just going to keep plowing through and go with questions. And so first question for Bridget is from Gary Morishima asking, there weren't any graphs of juvenile Chinook. And how do you relate these, understand how all the information you showed relates to stock-specific impacts on different species? And I was just wondering if you could answer that.
Yeah, thank you for the question. So the graphs for juvenile Chinook, so that's referring to the Southeast Alaska survey results I showed for juvenile salmon. And correct, I have the 4 of the species and not Chinook. To be honest, I just haven't received them yet. This is what I have to date, and they're still, I think, working up the Chinook. So I apologize, I don't have them yet here. I haven't seen them yet. But how they relate to stock-specific impacts for these graphs, for the juveniles, I think, and I think there's a lot of greater expertise on this call than what I have about salmon, but I would assume that we can talk a lot for all these conditions that we've been presenting of say, the early marine survival of the younger years and how that might impact returns. So looking at some of the past years. So I agree, looking at 2023 of juveniles, that's not going to inform you about returns this year. But those data from a few years back, depending which species you're looking at, do have some information that I think can inform returning stocks this year. And so, and I know there are other impacts besides that early mean survival that can influence the returns. But for example, we did see for the juvenile lengths, there was a dip across the board in those species in, I think it was, actually I can look, 2018, 2019, a little bit 2017. And then we had some really low returns in about 2020, 2021 of some of these species. And that was just coming when the Gulf of Alaska was really warm and our ecosystem had some cumulative impacts for a while on lower production and lower prey. And you could see that also in that smaller length anomalies, we had lower returns. And I know we can't directly connect those dots, but I think that provided some context to perhaps what was happening on the returns. And so I would be interested, I mean, I really enjoyed listening to all this and the thought process of what would connect with salmon, but that did cross my mind if you were interested in this type of presentation next year. I don't know, perhaps 2023, I'm not sure which years you actually would want to hear about. And we do have a lot more well-rounded information of some past years than current years, as you saw. So different ways of thinking about what's the most informative information you would like. And I would be interested to think about that in the future if you wanted to continue this conversation.
Great. And I was actually involved in the SECM study back in the early years, and they just don't catch very many Chinook, especially compared to pinks and chum and sockeye, which are the overwhelming species as well. Laura, you want to take a question?
Yeah, so another one from Gary Morishima for Jennifer. It's 2 parts. So part 1, the opposing trends of herring and anchovy were striking. Do you have any comments on implications for survival and productivity of Chinook and coho, particularly anchovy and Chinook?
No. It is interesting. I think we're not the only, the H0 herring survey in the state of Georgia is not the only survey that's seeing this uptick in anchovy. And so I think it's becoming, I mean, it goes through cycles, of course, and I think we've seen it an increase in recent years. And so that might have good implications for juvenile salmon survival, depending on if the juvenile salmon are big enough to eat them. So I think the juvenile salmon, coho and chinook, their biggest challenge is to get big enough so that they can eat the anchovy and the H0 herring, which I think is, you know, it depends on when they enter the strait and how big they manage to get while those fish are still around. So that's all I know about that.
Thank you. And then the second part of the question is, do you have any information on the status and trends of stellar sea lions? So more and more in our lower 48, they're becoming an issue. How about up north?
Well, yeah, I think the latest survey, I think, was done in 2017, and I can send you the link to the latest status report for those. And when they did that survey, it looked like perhaps the adult non-pup counts had increased a little bit, but maybe the number of pups born had sort of maybe leveled off a little bit. So yeah, I think the indication is that at that time they were still increasing, but I don't know since 2017. But I can put the link to the latest assessment in the chat.
Great, thank you so much.
And I've got a question from Gary for Andy. Andy, can you comment on the relationships between marine heat waves and both precipitation and drought?
Hi, sure. I actually wrote him an answer, but I'll verbally say it again. I can't specifically comment on the overall pattern, but what we did notice last year, and I think this is probably still somewhat in effect at other times, was that those low pressure cells that I was talking about, when they crank their way across the ocean there, those also tended to be the sort of steering force between basically those atmospheric rivers that kept hitting the Pacific Northwest last year. So they essentially, the low pressure comes across and the high pressure is sort of down the south, and as they squeeze together, that gradient in between is right where the atmospheric rivers form and then slam into the coast. So last year we had the heat waves came in June, and that was late June, and that's also when those atmospheric rivers hit the Pacific Northwest. So one's not, the heat wave is not particularly driving the atmospheric river or vice versa, but they're both related to the same overall basin scale kind of atmospheric forcing. So there's a connection there between both of those events happening, but I can't really comment on what's driving the the prevalence of those low pressure cells themselves. I'm not an atmospheric specialist by any account. So, but yeah, there is some connection, definitely.
All right, I have a question from Susan Bishop for Jennifer and Bridget. Have you seen any indication of habitat compression in your areas that indicate a change in distribution or increased density of prey and predator? For example, increased density of Chinook coincident with prey like herring or anchovy?
I don't know, do you want to go first, Bridget, or do you want me to try? So thanks for the question. I don't know the full answer. From the surveys and the reports that we get at the State of the Pacific Ocean meeting, I think that they've seen changes perhaps in some groundfish distribution with changes in water temperatures. But I don't know the answer in terms of overlap between salmon and their prey. I know that with herring, we have a couple different surveys, and I don't think we've really seen a change in, or a compression rather, in herring distribution, at least in the summer foraging areas. And then when for spawning, again, I don't think we see that coincident with salmon per se, but I can't say for sure. Sorry.
Sure, thank you. Bridget, any thoughts?
Yeah, I can add, I don't, I haven't for sure seen a change in or habitat compression in this context. We also haven't really, I don't know of anyone who's really measured it. And I think it's a really interesting question. And I know how the Southwest has been doing that and looking at whale entanglements, et cetera. This year, it has come to my mind because there has been an uptick in Eastern Gulf on some whale entanglements that it might not be a trend. It might just be a few more than normal hitting the news, but we also have this warm water off the coast, and it might be an interesting measurement to look at, similar to how you're looking at it in the Southwest. One other thought that comes to mind is for us, Prince William Sound, which is kind of the northern Gulf, due to various oceanographic dynamics, their oceanographic conditions and like temperatures are often a year lagged from what the broader shelf experiences. So when the kind of central Gulf shelf warms up, really the Prince William Sound stays a little cooler until a year later, and then it warms up, and you can kind of see this lag in temperatures. And so as a result, when we have these kind of big marine heat waves that have hit more recently, there is a theory that that area becomes a bit of a refuge almost, and they start to see more shelf species come into Prince William Sound in higher biomass than they've noticed before, just for that kind of year where it's a little cooler. So again, different than habitat compression, but changes in distribution related to temperature, and you might get some different overlap, and definitely salmon come into play in that area. I don't have any answers, but it's an interesting area to look at for that question.
Fantastic, thank you.
So we have a question. Jennifer, I know that you are an ocean person, not a freshwater person, but Urs is asking about the impacts of the forest fires in BC on salmon. Care to speculate on what you think might be happening?
Definitely not my area expertise, but I also worry about the level of forest fires. It seems like everything's on fire. It's super concerning. And I know that it leads to loss of shade on streams and slope destabilization and landslides, which are all can affect salmon, but I am not the expert on that, sorry.
No worries. I guess I had a question for Andy. You know, these climate models you mentioned were kind of getting out of past territory. And I was just wondering how well the climate models really work in this new era. Are you seeing, you know, kind of like whole new understanding of how the system works, or is physics really physics?
I think the physics is still physics. The one thing, I don't know if you've been following, there's quite a few papers now talking about how some of the traditional large basin scale indices are not as well decoupled. So for instance, the PDO seems to be more tracking ENSO signal these days. And so I don't know if you've seen it, but the latest forecast is you know, we've had PDO negative, but you know, now that ENSO is positive, the forecast right now is that PDO will go to positive as well within the next couple months. So, and then the other one is that the NPGO is no longer as well decoupled from the PDO either. So it's getting a point where we're not as much relying on some of those basin scale indices. Particularly the PDO is a tricky one because you remember the PDO is that measure of just the large scale difference in ocean temperatures, right? And even though we've been having all these coastal heat waves, we still have these negative PDOs, right? Which you think that does not make sense. But it does when the offshore waters are still super warm compared to the coast, right? So yeah, it's so last year, for instance, in our annual report, we basically, you know, normally we would rely on those indices to give us sort of overall ecosystem indications, and we kind of said, no, we're not really going by that so much. We're looking more at the local conditions than really relying on those some of those large scale ocean indicators that we've traditionally, you know, relied upon. So that's, I guess that's the new change. As far as the ocean models, they're actually right now, you know, for the short term for next year, they're all fairly consistent in what they're saying. So I think that's a pretty good message that We do think the current heat wave will kind of dissipate, but then we will be having, you know, quite a strong El Nino or moderate to strong El Nino next spring. It really won't come in though until February to March in most areas. So the further north you are, the later it will come in. So that seems to be a pretty consistent story among the forecast models right now. So I don't think the models are really failing. What I am more interested in is understanding what happened after 2014. Because if you notice, we've had just heat wave after heat wave, whether it gets into the coast or not, we've had heat wave after heat wave in the open ocean since pretty much 2014. And we had very few of those, if any, before that period of that kind of large sort of blob offshore heat wave. So I think there's been a sort of a shift that happened, and what exactly is behind that shift, I don't know. And I don't know if people know, but I think that's really the new phase to look at. Yeah.
Fantastic. Well, we are at the end of our time. I just want to thank all our speakers again. This was absolutely fantastic. We've got some links in the chat. Hopefully everybody sees those for different aspects of more information to get. And October 25th is our next seminar, and it's going to be fisheries management structures that deal with climate change. So we've got Rishi Sharma, who's been working with the FAO in Rome, and he's going to be talking about kind of climate adaptation across the globe. And then we've got Tommy Moore from the Northwest Indian Fish Commission, who's going to talk about, I believe, tribal efforts to deal with climate change. So come back, and thank you again to our speakers. That was absolutely fantastic and fascinating. And really, really appreciate it. So, see you all.
So much.
Thank you.